Now think about this one. We have a store. So you are the manager of the store, and then every day we get customers. So we may get girls and boys, female, male type of gender based customers, as well as we get different types of request demands for our products, right? So if you think about the context of the store, you may be selling child products, so children's care products, and then also for toddlers, and then maybe shaving cream and men related products, as well as female products, right? Many types of such products, and also groceries, bread, etc., etc. So we may have an inventory of what we have and also what we sell, right? And sometimes when we scan the tag, sometimes we get like missing values. So sometimes you have to say that the cashier issues somebody buys 3 milk cartoons, so he or she is only scanning the cartoons while he or she issues the product, and he or she forgets, the cashier forgets one item. So there's a missing item, right? And when we try to analyze the data at the end of the day, how much of our sales are and also what has happened during the day, then we will be facing a lot of issues because there are missing values, as well as the accounts don't tally. So such problems can occur. That's one example. Then there can be another example here, that you bought a sensor to record temperature data and maybe moisture and temperature, moisture, some other, let's say, pressure of a certain refrigerator or a certain storage facility. Now, maybe because of an erroneous result in the sensor, and also there may be some other unexpected problems, then the sensor may record a certain temperature but may fail to record the pressure, right? So there can be missing data because of the issues in the sensor. Likewise, there can be many problems. Now I'm going to show you a data set. So first of all, let me show you the data set, not this one. Right. I'm going to show you this empty cars data set. First of all, let me show you this data set. Now in this data set, let me open recent empty cars. Right. In this data set, you can see that some of the data are missing. If you take a look at this one, this particular data is missing. And also there are empty cells as well. So this is the typical data set that you are getting. If you ask your seniors who are doing research programs, research projects these days, they will confirm that some of the data set that they receive, and also when they acquire data sets to do their research projects, they don't get data for some time. So if you do a survey, you will not get a particular response from the people. Therefore, there will be a lot of missing data, and also this kind of empty cells, and also in some cases you may get these type of characters that don't belong to that particular data set. So here we have numbers, but this question mark does not belong to this particular data set, right? I mean this column. So you will find this missing data as well as mismatch data types when you do the analysis. But you need to identify them in order to prepare your data for the analysis. Otherwise, if you don't do this process at the beginning, then I'll show you what happens. Now, if you go and try to get this data set, for example, let's say that here we have this HP, horsepower. Now you have this question mark here. If you go and try to get the summary of this data, say you want to get the mean horsepower of this particular car data set. So if you go and do the analysis and try to get this mean value here, you will get an error because there is a missing value or a mismatched character in the data set, and also a missing value here as well. So you have to clean this up in order to get the mean. Okay, so this is the process. If you don't follow this basic routine, then your analysis will not be possible, right? So that is why we do this data wrangling process as a whole. This is a pre-processing task. Now, some of you might not be familiar with these things right now because you could not join the lecture previously, but I have given the necessary details in the Moodle. You can go to the Moodle and see all the recordings, and the lecture files are available here, and so as the reading materials as well as the exercise files where you can do the exercise. I gave an opening for Python exercise part 1 to upload to the Moodle. But for the previous lecture, I didn't put any link because I was thinking to give an assignment for today's work. So once we complete today's task, I will give a bit of a briefing about the assignment. I think you can also go and read about this one. So because we are fresh in the lecture, I'll give you a bit of a briefing upfront. Now, this is the assignment you have to do. It's an individual assignment. You have to do this data wrangling assignment. I'll give you like 2 weeks to submit. If you want, I can extend it up to 3 weeks, but my suggestion is to complete it within 2 weeks, because that will be helpful for you to focus on your other exam materials and things in the future, rather than dragging this to too much of a time. But I'll explain what you have to do. Now, when we do the data wrangling whole exercise today, you will learn how to treat missing data, and also how to do some of the tasks that we are required to do in the data wrangling pre-processing process. So you have to include those things. Now, this particular report has a this is, we call it a cover page. So you have to prepare it like this. But I can understand if you can't really do this one as is. But I strongly encourage you to prepare a cover sheet similar to this one, with the with this wording on the top, with this page outline and the page numbers and everything. So it's a good exercise for you to practice using Word. Or if you are good with LaTeX, because I made this one using LaTeX, you can use LaTeX to build this one as well. Now, the name with initials, index number, and lecturer is my name with designation, and the word count, excluding this part. Okay, excluding the front page. You can put the word count for other body of text, and then number of pages, number of figures, number of tables. So the report outline should look like this. You should have an executive summary. So starting from the executive summary, you will count your word count. So the maximum number of words for the executive summary is 200 words. And then the data wrangling plan. So it is more like the maximum is 5 pages. You can include figures, tables, logical sequence, like a little graph or something, how you develop your codes, and then the print screens of the code. So it's very simple. You do the process and take a print screen and put it there, and also indicate the figure number and cite where necessary. The section should contain the following key elements. But this doesn't mean that you have to include this order, okay? So it means that these key elements should be there. You should introduce your data set, and then the key characteristics of the data, logical sequence to do the wrangling process, and then the screenshots of the steps, automation of the workflow, things to consider. If you are going to automate the process, like things like these will appear again and again when you are working somewhere. So you can automate the process. Like if you are going to take the data set, similar data set will be given to you in the future, you can automate the wrangling process so that you just put it there and then pre-processing will automatically happen. And then you take the wrangle data at the end. So think about how to automate the workflow. So by that, it's more like an algorithm, like check for the missing values, rename the columns. Likewise, it's a process. You can actually do that one. You can automate this workflow. You may not include these elements in the prescribed order. As I said, you don't need to follow these names, particularly these names, but you can go introduction, methodology, how you did it, so on and so forth. And however, you should show how you have included them in the sections you created in the report. The Python language to complete the task should be strictly followed, because this can be also done using R, but I want you to complete this using Python. Please upload the Wrangle dataset as separate CSV file. I'll open the link for that. So name this one as your index number dash wrangle data.csv. So your index number should come first. Please note this one. Your index number should come first, because then only I can, I can look at the data and give marks easily. Please follow this format. It's very difficult to find one, again and again here and there. So index number dash wrangle data.csv, that will be the thing. So if your index number is in front, that is also enough. Right. So the assignment briefing, use the data set provided in the Moodle for the assignment. If you go to the Moodle 3110, you can find that there is a set of data available in the Moodle data set for the assignment. So if you click on this one, you can download this one. It's 12.1 MB. You can take this data for the assignment. The data set, okay, and then these things we will discuss today while doing the lecture: identify and handling missing data, etc. So the data set variable description is like this, because you might not be familiar with the data, and that is understandable. So for each column name, I have given you the description of the data. So what is the meaning of the column name? So here, as I mentioned, this is an empty cast data set. So we have this MPG, cylinder, displacement, horsepower, etc. So similarly, we'll find these names and what they mean have been described here, because when we do today's work, you will understand why I have to give this one, the amount of the transaction, online transaction. Right, maybe there is an error here, but check that out. You will understand what you mean by the name. Maybe I missed the name here. Just check with the data set. Right, now that being said, let's go to the work today. So this is Python exercise file for today's work. So you can see that I'll give you a brief introduction first, and then I will go to the work. Now, today's task is actually doing a data wrangling task without doing any theory or something, just how to look at data and then why data wrangling is important. That is the whole process of it. So before going into this with Python, let me do it using the Excel version of the data. So this is a CSV file. I have opened it using Excel. I will show you why data processing is important. So I got a chat message. Is it heavily running here? May I leave the session? And yeah, it's okay. I'm not forcing you to stay. If you have find some problems, you can leave. I will upload the recording anyway, right? So no issues. But I wanted to have your attention here because it's good to participate in the lecture. If you have any problems, you can leave. No issues, right? So okay, I will be explaining this now. Now, when you have this type of a data set, first of all, if you can open it using Excel, please open it, because that will show you a lot of details compared to any other programming language or opening, because it's easy to see these kind of missing data, right? So the first task here is actually opening the data set using Python. So importing Numpy and then importing Pandas. Then I just gave my path, the longer path, and then the file name, and then I concatenate the path and the file name so that I can easily put the string file into my pandas read file. And then I have taken these rows and columns because I have to just this is a generic way of following in the Python itself. This is kind of looking at the data from Excel. Now here you may find the number of rows and columns easily because you have number of columns 32 rows, and then you can go and see how many columns are there. I think 12 or something. So you can easily get this one from Excel, but when you import it to Python, this is the way to get the values. Now you can also rename the columns if you think the names are not appropriate. Like the case of this cylinder, if you don't understand the word, you can rename the columns. Now in the case of Excel also, you can do it. I'll show you the parts where it's difficult to do using Excel. Now here, if you want to get the null values, so these are null values and kind of missing values, you have to apply the filters in Excel. But in the case of Python, you can easily do it using isNull commands and check for the missing values. And then we can replace some characters. If you now these type of things, now this character, I know that because I have inserted it for this exercise sake. But in the case of real world data, you might not know what this character, or is there any type of character in the data set itself. So you have to first investigate the data like this. Now, when I look at this one, I can easily see that there are question marks. Also, if you open it using Python, you can also check that one and then see what are the characters and what should we do in order to get rid of them, and then come to a consistency in the data. Right. After doing that, there are some tasks that I have done all the way to standardization, binning, and indicator variables. Now, without further ado, let me start my Python program and then run it. So for those who are using Windows, I think you can run it using the command Anaconda prompt. You can write notebook there. Then it will automatically open this one. Otherwise, if you are using a Mac version, you can type this one on the terminal as Jupyter Notebook, and then it will open this this file notebook, and then you can go to your file and open it. Now, please follow me if you can. Otherwise, please take a note of it, what I do here. Now, first of all, as I told you, I'm going to import Numpy and Pandas. What they are have been done in the previous lecture. Now, provide the path as a string file. I do this because now if you look at this path here, it's a very long path that I have stored my data in. So I don't need to see this string again and again and again in my codes because it's too much. So I gave the path separately and I gave the file name separately, because if I need to get the path, now in this case, I did I did a silly thing because I concatenate the path and file name back to the same path variable. But you can have path 1 and path 2, and then path 2 for this reading stuff, and for writing you can use one path like the destination itself. But for this exercise, I have just used path as a variable and then concatenate the file name to that one. But that's a good practice because you don't have to keep on writing this extension, the whole thing again and again. It's easy to do this way, right? So I have created this path file. So let me run it. Now my path contains the file name as well as my path to the file name. So if you print this one out, you will be getting this one, where are my data set and exactly what is the data set here. So done. Now read the file using pandas read CSV command. So we need to input the path, file name path, to the read CSV command. So data is equal to pd.read CSV underscore CSV path. So when we do this one, Pandas will automatically read the CSV for us. So when we shift enter, you can see now for the missing values, for the missing cells, it has automatically put NaN here. That means not a number has been automatically assigned. When you do the Pandas read CSV command, it automatically identifies the missing values. So you can see It's an NA in here. If you go back to our data set, I think this is empty cast copy. That's here you can have these missing values, and then you can see those missing values have been identified in the data set itself as NaN. Okay, but interestingly, you can see that. Let me check my email. Right. So as you can see, N names are there, but the question marks are also there. Now, this is a problem. N names can be easily taken down by Pandas inherent commands because we know that it has already been identified. The missing values have been identified as NaN, but the missing the characters that indicates the missing values have not been identified as NaN. So we have to first of all treat this problem, right? So this is how the data looks like, but because it's a short data set or a small data set, you can see, I think, the whole set, 32 of them. Yeah, whole data set can be seen. But if it is a very large data set like the one that you have received for your assignment, you might not see it fully. Sometimes it's just the head. So if you say data.head, it will show only the first 5 rows and then the column. So this is a good practice to see what are the column names, right? So I have checked this one now. I see that there are column names here, and this unnamed 0 indicates that this particular column has been named as unnamed 0. If you go to your CSV file, you will notice that this particular column does not have a name. So it is identified as an unnamed column 0, right? So MPG and other things are there. Now inspect the number of rows and columns in the data frame. So if you take a look at this one, 0 indicates this side. So it's the vertical side. 1 indicates from left to right. So so the data shape 0 means axis that goes from the vertical side of your screen. Data shape 1 means that goes horizontal side of your screen, right? That's easy way to understand it. So when we say data.shape 0, it gets the rows, number of rows here, and then data.shape on the other side, it will give you the things. But basically, what this data.shape gives you, let me do this one. So this is 3212. But if you run this data.shape alone, you will get a list. So you get this one. This we call it a tuple because you can't change it. 3212. So entry to this one is 0. 0th index is 32. The first index is 12. So that's why we put this one 0 and 1. But easy to remember because we are dealing with data frames. Rows goes as the vertical one and the columns goes as the horizontal one. So 0 indicates the vertical number, 1 indicates a horizontal number. These are not, kind of theory that you might, but these are from practical cases so that it is easy for you to remember. Okay, so you know that directly if you got data.shape 0, that means the rows, data.shape 1 means the columns, right? So once you get this one, you can get the rows and columns as is. Right. So now, so far what we did was we imported the data, right? And then we took the data.head to see what are the available data and the names. So we already knew this one because we have seen this one using Excel. But, when we imported it to Python, we can now see that one using the Python commands as well. So we check the data heads, and then also we check the rows and columns, number of rows and number of columns. Now, by this point, as an analyst, you should have an idea. Okay, I have a data set which has 32 rows and 12 columns. There is no harm of taking a piece of paper and writing this down so that you have a picture of what you are doing. You have 32 rows and 12 columns in your data set. So you have an idea about the type of data that you have, the structure of it, and things you have to do. Now then, Then if you are not happy with the available data, you can rename them. For instance, now unnamed 0, unnamed colon 0, I'm not really happy with that. I can put that one as name because I know that it's a data set of cars. And then I'm not happy with this simple MPG. I'm going to make it capital MPG, miles per gallon. And then cylinder, I'm going to rename it as cylinder. You can do others as well. This is just for the exercise sake. So it's a dictionary. Now remember, columns have names. So the column names indicate the variable, right? So the variable values are followed by the row values. Okay. Now we can rename this column by using a dictionary. So data.rename, inside the brackets, you can write columns equal. Now it's a dictionary. If you remember your dictionaries, dictionaries goes as like the index number, index is there and then the value is there. Index is there and the value is there. In the case of this particular exercise, columns indicate the value. So unnamed 0 means the first column name. So we are going to give a name, the re-indicate in the value that we want to indicate. Okay. So unnamed 0 become name. And simple MPG becomes capital MPG. Cylinder, I want to rename it as sil. I want to rename it as cylinder. In place true means you if you don't do this one, it doesn't alter the data set itself. So I have to make it in place equals true. Now, when I do this one, I can refer to the data set following the new names, the names that I have given to it, right? So when you are doing research, in your next semester, in your final year semester, first semester and second semester, you will find different data sets, but you have to make them to a structured form in order to run your machine learning algorithms and all. So you have to make sure that you understand the data variable and then name it. Now the same thing, that is why I showed you in the assignment work that I have given you. The columns have different names, but what they mean have been given to you in the assignment briefing. So it's up to you to put a meaningful name to the column as well, because that helps the analyst part. So that is an important thing to do. Now, when I run this command, you can see that the unnamed column here, I'll just put data.head here to avoid the lengthy descriptions. Now I have the name here. The MPG has been changed. Cylinder has been changed. If I want to change the other things as well, I could have done them. And also with the case of a dictionary, you should by now understand that I don't need exact order as well. So if I want to change this gear per se, if I want to make it a capital letter, without putting them in order, I can easily put the gear here as the index, and the renaming value can be given to the next as the next argument to it, right? So then the dictionary will automatically rename the column here. Okay, so it's better to put them in place because you are going to carry on the analysis using the data set, right? Now up to now, I think it's clear. We have renamed the columns and we have imported the data, but we haven't touched the data itself yet. Now it's the time. Now we know that there are some non-value cells and missing value cells. So missing value cells have been already identified as none, and the characters, question marks, are there. So we have to understand what to do with it. So the check for the null or missing values in the data set comes now. Checking the missing values in the columns, you can now, if I run this one without this dot any, right, you can see that we get a matrix. It's a data frame with false indicating is null is false, right? So remember that when we do this one, it's like a logic. I'm asking Python, data is null. So is it null? So Python is telling me no, false, false, false. When the data is there, it is saying it is false. But when there is no data, let's look at this third row or the fourth row, and the last next to last column here. You can see it's true. Now it has identified the non-value cases, but if you look at closely, okay, can you see that the fourth one, it doesn't identify this question mark. It says it is not null. We know that it doesn't have a value, but Python has identified it is having a value. So is null is kind of giving us that false impression that there is data here, right? But we know that the data does not belong to this column. It's some mistake or a missing value. Okay, right. So when we type .any, what will happen to this one is it will give us right now. So based on the variable, whether there are any null values. So for the name, it indicates all the names are there. For MPG also, it says everything is there. Now let's look at VS. VS, it says true because not because of this one, okay, because there may be some other non-values at the bottom. But the thing to remember is that is null cannot identify these question marks or any other character that doesn't belong to the data. It can only identify the non-values, right? So if we go and do the is null sum, we'll identify the number of rows that contain the null values. So here, when we do is null.sum, so it's an aggregation of what is available. When we run this one, you can see the number of available null data points here directly. So it is very difficult to do it using Excel. So if you want to if you want to get the null values, there's a way to do it actually. So you can go here and then just apply a filter. Once you apply a filter, you can go here and check, uncheck the select all and go here and check for these question marks and blanks. So when we do that one, you can easily get the, give me a second. Right. Okay. So now when we look at this one, you can actually get this one using the filter command. Right. So when we do the sum here, sum command will automatically calculate the available null data points, and then it will show you what are the data points null that are null here. Right. When you do the not null, it indicates the data points that are there. So, right. When we have it, obviously, if we now, I'll show you something. Data. If you go to data and check this VS, now VS has a null value. Okay, so VS has a null value. Right. Now when we run this one, it has now VS has a null value as well as a question mark. Okay, but when we run the not null sum for VS, it shows 31. Obviously there are 32 values because it has only identified one missing value here. Okay, it has identified the missing value as none, but it does not identify that question mark as a null value. Right. So I hope you understood the context of this one. Okay. So now we have a problem in this particular data set. We have a missing data set like empty cells in CSV and a question mark. Of course, question mark is something that I have created. You can have many other different types of missing data characters or some sort of a signal that comes out of a sensor or some value that indicates, if you are going for in the future, if you are working in this financial industry, or credit cards or something, things related to these things, you may have different types of characters indicating missing values, not only null values, not only in missing empty cells. There will be some characters that indicate it's a missing value. So in like, it is not easy to directly identify them using not null or null. So you have to first of all explore the data to identify what is that character. Now, I think none values are clear. So replacing the question mark or any type of this character with a none value is what you have to learn, because none values automatically will get taken by the Python programming. But for replacing a character with a none value is what you have to remember. Right, now I'm going to replace it. Data.replace will replace the first argument is the thing to replace. Okay, so data.replace, the first one is the thing that you have to replace. I have to replace the question mark. With what you have to replace it? With the numpy nan character. So numpy np.nan indicates a numpy null value. So it's a null indicator. So I'm going to replace the question mark with this null indicator. Question mark with np.null, np.nan. So now when I run it, you can see now it identifies the question mark as a null value. Now if I go and say I do the same thing, data.isNull .any, I'm going to stop this one. So when I do this one, you should get 30 count sum. Now you should get for VS, now you got 2, because now the question mark has been identified as a null value, right? Okay, so I think that's straight, that's understandable, right? Now let's go to the next step. Now once you have identified and replaced this data set with the NANs, it's easy for us to pre-process it and also continue our analysis from there. The data pre-processing needs to treat these missing values. We need to replace the missing values with appropriate values. So it's like this. Now that's a very good part of this lecture. Let me kind of write this one on the screen. Now, I guess you can see it if I write it here. Okay, now this is the thing to remember. Now, let's say that you have X and Y. Okay, this is a very simple thing, but I wanted to explain you because it's a very interesting concept. Let's say that you have a value here. For X1, you have Y, say 3. And for X2, you have 5, Y5. And for X3, you have a missing value, NAN. And for X4, let's say that you have 10 or something. Okay. Now, when you have this type of a missing data set, what can you do with this one? First thing that will come to your mind is to exclude this data, right? So the first thing you might think doing is excluding this data. But I am advising you not to think this as the first alternative. Always think that maybe you can replace this data with something that describe the data set, right? Something that describe the data set, that describes the data set. You have learned this one under descriptive statistics. That is why you learn these things. So you learn this one using descriptive statistics, that you can describe a data set using different numerical values. So what are those values? To name few, mean is a good descriptive measure. Median is a good descriptive measure. And then you have min max, range, right? Interquartile range, Q1, Q2, etc. And also you can have mode. Of course, mode is a very good measure in some cases. And also if you are more interested in the gap value, you can use these two values and get the average of that. So you can use many ways to fill this one. So if you can fill it in a meaningful way, of course, you can replace the data with a you can fill it and then get the use of the data. Otherwise, when you exclude the data, sometimes it's very difficult to get the data again. So capturing data is a very expensive process. Therefore, it's very much in need to try to use whatever the data available to the best of your ability. Now, if you remember, I'm just curious, if you remember this thing, this 5-number summary plot, this is Q2, this is Q1, and this is Q3. You have this interquartile range, and 1.5 of the interquartile range belongs to what? Outliers, right? And then from there you have these extreme outliers beyond this one, extreme outliers, and also any point that belongs to here you need to exclude from the analysis because they are anomalies, right? You remember those kind of descriptive measures. So sometimes you may need to consider those as well, but it depends on what you really want. Okay, now in this case, so coming back to what I was explaining here, in this case, where we do this analysis, we can actually do a very simple filling. So to do that, what I do is, now in the case of QSEC, you can see this there are NANs. Let me open a data set here just to show you this one data. Now QSEC, if you go down here, you have this NAN, right? NAN is there, and then there's another NAN, and then there are 3 NANs, missing values. So what I do here is that I take the average of that thing. So you remember how to filter out and get the value, how to filter out the value and then get the aggregated statistics, if you remember. So what I do is I take the data QSEC from the data frame. I extract this QSEC data frame, this column, and I get the data as type float and get the mean of it. So what I have at the end is the mean of this column. So that is the average. So as you remember, average is a good descriptive measure of the data set, right? So average QSEC I have calculated like this. Similarly, I took the average cylinder as well from the cylinder column in the data frame data. I took them as type float, that is to indicate that I'm taking them as a floating value, and the mean along the axis 0. If you remember now, it's easy to remember because I told you axis 0 indicates the vertical column. Axis 1 is a horizontal column. Horizontal axis. Vertical is axis 0. Now average of cylinder and average of QSEC, I can easily get these values. So average of cylinder 6.13, average of QSEC 17.73. So what I'm going to do is, remember the same command we used previously to replace. I told you the first character is what to replace and the second character is what to replace it with. So the replacing one in this case is what you have taken from that. So QSEC, average QSEC I have calculated from this one. So I'm going to put it in place of np.nan in place true. So in place of nan, I'm going to fill this. So it's kind of replacing that. Now when I first of all, let me check the data here. I'm going to insert a column, insert a cell, and then I'm going to extract that, filter out that QSEC just for the sake of showing you. So you have NAN values here, right? So now when I run this command, when I extract the NAN, when I replace the NAN with the average value, and then you can see that for particularly, let's say the 8th value NAN there is replaced with an average value. So average QSEC. right? So because it is more appropriate to fill it with an average value, we took the chance. But I can't teach you what to do, because for each data set, things can be unique. Even the case for your assignment, please look at the data set properly. You may need to get the frequency distribution, maybe draw the curve as I showed you, maybe a linear curve or something. Just draw a XY curve or something, then see whether this fits, whether this missing value, if I put the mean value, whether it fits. Now I'm going to do the same thing for the cylinder. When I do it, now I don't show the data, but cylinder will be automatically replaced with the average cylinder value. Now, you can apply Python loop to automate this process. Okay. So up to now, what we did replace the question mark with the null values. And then we took the null values and replaced the null values with an appropriate value that we deem would fit the data set, right? So it's our judgment. We look at the data set and we fill that data set with the missing value with the value that we assume correct. Okay. So actually, we can automate this process. We can do it. First of all, check the names of the columns. Data.columns will give you the names of the column. Now, as you can see, these are not the original names. I have renamed them, if you remember, using a dictionary earlier. Now, these are the column names that we have. Now, I'm going to loop it using the for in command in Python, for head any variable, for head in this data columns. So these things are the values. If data dot head is this value, is null, any equals true, which means if I take a column and check that whether there are null values. Now remember, when we come to this point, we have already replaced any of the missing characters with NaN. Okay, to do such a process, you have to make sure that you have done all the necessary process up to now, that all the missing values have been identified as null values. Okay, so when I run this one, data head within that one is null, any is a true. And so I have to make sure that both of these logics are done. So, and data head D type, that is the data type, is integer 64, float 64. Okay, so that's a value. Then the average data inside this column as type float, mean axis 0. That means to get the column mean and fill the mean value with the average value. So that's what I did. So what I got was these values for each of the so average is for this. These are the average values. I haven't replaced it because I haven't done any command here to replace it. So if I want to replace it, data replace, I can run this command inside the loop as well. But I haven't done it because I just want to show you. Now, I come to this interesting part here. If you look at the cylinder values in the data frame, look at the cylinder value counts. You can see that an interesting thing has happened here. Now, I think those who are familiar with cars and motorcycles and all these things would know that there are the number of cylinders is an integer. It's not a decimal number. So either you can, when you export it, you can make it an integer value, or I will show you another trick that may or may not be correct. I mean, depending on the data set, but I'm going to show it, so that you can use it in the future. Now, here, as you can see, 8 cylinder, 4 cylinder, and 6 cylinder, you have 12, 10, and 17. 12, 10, and 7 vehicles here. And that's of course for NaN values that we have replaced it with the average. You got 3 vehicles only. Either you can make them all 6 cylinders, or you can follow this trick. Now, what I have done is sometimes we need to replace the values with a different descriptive measure, such as mode, just to show you that we can do that. So maximum frequency of the data cylinder value counts, the maximum frequency is 8. As you can see, yes, 12 cars with 8-cylinder engines. So when we do this, when we take the mode of it, you can see that there are 8-cylinder vehicles. So that's the maximum. So what I'm going to do is I'm basically replacing the NP none, the not value or the null values with the maximum frequency of the cylinder, just in case, just to have just because I can. But that may or may not be true, because you have to just check whether the Hornet 4 drive is 6-cylinder or 8-cylinder. Hornet Sport bound is 8-cylinder. Check with the data set and see whether that is appropriate. Otherwise, you can go with the as type integer, or you can make in the data set the replacing values as integers. You can follow anything that you like. But I just want to show you that it is a possibility to use any type of a descriptive measure to fill up the NP-NaN values, right? Now, up to this one, we have fixed the missing values where possible. We need to drop the remaining missing values which cannot be adjusted. So even after following many pre-processing tasks, if we cannot fill them, right, it's like a jigsaw puzzle. So it's like you have done so many tasks to get the big picture out of it, but there are missing pieces. So we have to live with what we can't actually fix. So we have to remove those missing values which cannot be adjusted. So data drop now will give you that the possibility of dropping the value. So data.drop NA means not a value, things can be dropped. So if you remember this command, data drop NA, even if you don't remember the command, if you have an idea that this can be done, then you can actually search it. So data.drop NA subset. So the subset that we choose, that's the column, is disp. So displacement column, we have an NA here. So axis 0 is the vertical direction. So in place true, yes. What I'm going to do, I'm going to drop the data. So data drop. I'm going to drop these things, and after drop, I'm going to get the column count. Dropping means we remove the entire column. Entire row. Sorry, we remove the entire row. So I'm just getting the number of rows here after the drop. So when you do this one, it automatically removes the null values from the thing. So after the drop, number of drop rows is 3. I just did some math here because rows I have already calculated earlier when I imported the data, if you remember. So I just took it, and then after drop is obviously a lesser number. So I took the difference, and then the number of drop rows is 3. So which means this NaN has been dropped. So if you want to check that out, of course, you can now check data.head. If you run this one, you can see the NaN has been removed. So NaN belonged to Hornet 4 drive. Now Hornet 4 drive is not there, right? VSNaN is there, but we dropped whatever missing values from the displacement, right? So you can actually write a Python script for this one, similar to this loop command. So for head in data columns, you can check all the heads and then ask to drop it. So drop whatever the rows that are missing. So it's very difficult to do that using an Excel. It's very convenient to do it using Python. So you can drop all the missing values, and you left with a single set of nice data frame. So once you do that, you have to, of course, reset the index after dropping. So that helps. So now we have 29 to 12, like 29 rows and 12 columns. So we didn't drop any column. Okay. So we took 29 rows and 12. So we check now. After doing all these things, now we have to use this data for analysis, right? So in order to do the analysis, we have to be aware of what the data sets are, the available data types. So data.d types will show you the type of data. So there are problems here. I'll come to that in a moment. Now, when we do data.d types, it will give you the column name, the variable name, and what type of data that is there in that column. So in the case of name, you have an object, mpg floating number. So float 64 others. And then if you closely look at this one, cylinder is given as an object. I told you it should be an integer because cylinders, they have to be a countable integer number. Numerical variable should have type float or integer, and variables with strings such as category should have the type object. For example, MPG and cylinder variables are numerical values that describe the engines. So we should expect them to be of the type float or integer. The cylinder is shown as a type object. We have to convert data types into proper format for each column using the as type method. So if you remember, in your third learning outcome in your subject, the third learning outcome is related to identifying this data type. So data types can be different, right? Floating numbers can give you these decimal values. Integers will give you countable numbers, only countable 1 2 3 4, like fingers. You have to have this whole number to count. So integers are like that. Floating numbers can have decimal values. So for string values, so strings, they are text values. So if you put a number as a string value, then it doesn't identify that it's a number. It will be identified as a string value, right? So data cylinder as type integer. I'm converting it to an integer. You could have done that one while we did that replacement as well. And for the displacement, I'm putting them as floating. So it automatically rectifies that one. Now, if I do data.dtype types, it will show you. Now it has changed to integer 64. For displacement, I have put float. For cylinder, it's an integer 64, right? So automatically change the whole data set into whatever I gave, right? Now, some parts to consider. Now, this is an important task. Data standardization. I think I will not talk about the data standardization in terms of statistics, but I think by now you are aware of standard normal curve. So you know why we standardize the data. When we do the standardization, it allows us an easy comparison between the data. Also, it allows us to look at the data distribution clearly. So what I have done is I have filtered out the data MPG. I selected that column and I converted that column for all row values. I have done this calculation 235 divided by data MPG to convert. Now this is miles per gallon. What I have done is liter per 100 kilometers. So it's a calculation that you can find from the internet. So for every 100 kilometers, how many liters are needed? So then I convert this one and then I rename the columns again using a dictionary. Instead of MPG, I now put liters per 100 kilometers in place of that. And when I type this one, so it's a standardization. So now I know that for 100 kilometers, this particular vehicle needs 11 liters and this one needs 10 liters, etc., etc. So I convert this one to a standard form that I know and I can analyze. So when you get data sets, you might get data sets with different units as well. So it's very important to convert these units to a standard unit and a unit that you can compare it with. So when you do that, you are standardizing the data set, right? So this is data standardization. Now, then data normalization, of course, this is something that you know. For when we normalize it, we can divide it by the max or the minimum. So when we do it by divide it by max, we are restraining the data set in a positive quadrant from 0 to 1, because maximum divided by maximum is going to be 1, and minimum divided by maximum it's not going to be 0. If it is not a 0, it's going to be a positive value. So all the data sets will be squeezed into 0 to 1 range. So that's a normalization. So if we get all these data points to 0 to 1, so cylinder, displacement, anything 0 to 1, then we call it a normalization. So when we do this liter to 100 kilometer thing normalized, you can see rather than 11, 10, 12 kind of values, we can kind of see from 0 to 1 a standard normalized range for these values. Then actually it's very easy to classify. Now, if you learn about decision tree regression, decision tree classification, random forest, any sort of a Boolean tree, all these things belong to this particular numerical exercise where you convert a value to a standardization and then normalizing it, so that you are kind of segregating values according to a known range. So after that, it is very easy to segregate values, like classify values, because you know that nothing can go beyond 1 and nothing can go below 0, because kind of you normalize. The same thing applies for other normalizations as well. If it is a standard normalization, you know that it goes from -1 to +1. You can have this sine or tan transformation, like sigmoid functions, etc., -1 to +1. So all these transformations and normalizations will give you that range of values. Now, when you have the range of values, now at this moment, what we have as a data set, our data set contains of this liters per 100 kilometer value, the column with different values. Now what I'm going to do is I'm going to convert this into as type float. So I have this just in case, just to convert them into floating values. And then I'm going to inspect the values, how they are distributed. Now, as you can see, like this particular, there's one vehicle that has a very high liter demand per 100 kilometers, and also some vehicles are there, some classes of vehicles are there that has a lower demand, right? High efficiency, fuel efficiency, and mid efficiency, and this one is not really efficient. So what I'm going to do is I'm going to divide this into bins, separate bins. I'm going to use 4 bins so that I can categorize the data and see how they are distributed. So I'm going to create this bins here. So when you look at the code, you can identify, but I'll just move with the flow. So I created group names, and for 4 classes, 4 bins, you have 3. Like if you take, say, if you take your 2 fingers, right, in between space is 1. If you take 3 fingers, in between spaces, you have 2 spaces. So n minus 1, right? When you have 4 fingers, you have 3 in between spaces. So similarly, for 4 bins, I have 3 groups. So low, medium, and high. I name the group names as a list. And then I'm going to use that list and see which class belong to that low, medium, and high classes. So basically I did a kind of a data. Now I'm just processing the data. Now I'm doing the analysis part. I'm processing the data. So you can see that I've converted the values into a class like low, medium, and high. So when we take these bin values and get this count, you can see how many vehicles in the medium class, how many vehicles are in the low class and high demand class, like high use of fuel. And then you can actually get this very nice histogram out of it to get the analysis. And then you can get this full data set to process as I have attached a column indicating the low and high and medium demand of fuel. So I'm just following quickly because you have this one in your Moodle, so you can easily look at this one, and it will help you to process the other data set available. And the indicator variable means when you have this column data set, you know that these are the names. So when we have data, a dummy variable means a variable like this. So you have 1 and 0. These are numerical values. But now you in terms of this bin values, you have low and medium and high. So these are classes. But when we do regression analysis or any sort of numerical analysis or machine learning, The computer doesn't know the character, so it doesn't identify what is low, what is medium, and what is high. You have to give values for those things. So this is how we generate those values by dummy variables. Now in this case, it creates kind of a binary code to indicate low, medium, high sequence. So when we do that, when we do the concatenation, you can see that when it is low, it has identified as some 1 and then 101. There is a way that it has identified the dummy variables following the given axis, and then you can actually replace the low, medium, high with this dummy variable. So we call them indicator variables. When we do that one, it's the complete data wrangling process. So you can look at when you do data describe, you can finally come up with an answer about now here this indicates 27 because I didn't really drop the null values in the carb. You have to do that, right? You have to drop these values and then come up with the very clean data set to get the statistics. So this is the full process of data wrangling at a very basic level. Okay, this is not the final data wrangling process by any means, but this is the mindset that you have to do the data wrangling. You have to identify the data set, you have to identify where the data is missing, and then you have to identify what to do with the missing data, how to fill the data, and also you have to identify whether there are classes and conversions from values to classification, or from classifications to dummy variables, binning and classification. So you have to get the full thinking pattern going on with the available data. Now, I will upload this one as well. So since I have done this one, I will just upload the answer, kind of what you get for each of these PDF. I'll just do that and I'll upload it to a Moodle. But my request now for you is to go to your Moodle, right? Where's this? Go to your Moodle, and in the Moodle, you have this exercise file. I'll upload the result file as well. Just observe it and try doing it as an exercise for car details. So you have a car details CSV file here. Open it and observe what I have said here and try the same exercise on car details CSV file. But that is not the assignment. Okay. The assignment is, as given in the assignment brief, belongs to this data set. So it has a data set for the assignment. Do this one and indicate the following, like the process, and as I did, why do you this, why did you do this and that, and what did you obtain, all these things, and prepare the report and submit it. I'll open the links for all of them. Okay, right. So any questions? If you have questions now, you can ask me. If there are no questions about no questions and questions, nobody's asking questions. Right, it's okay. You will get the recording anyway, and then you have the files and codes as well. Please do this car details one as an exercise. I'm opening a link for that as well. Do this car details and upload the Wrangle dataset here. You can save the Wrangle dataset and upload it here. And for the assignment, you will have another link here for the report and also for the wrangled.csv file. Please do that as well. So that will be marked. That's an individual assignment. So everybody needs to upload a file. And for those who could not upload these previous ones, I have extended the deadlines. You can, for obvious reasons, others also, I guess, understand the situation. If somebody could not upload it earlier, they can fill this one up and then fill the missing submissions, but this one is a serious marking assignment, so you have to follow the instructions and upload it on time. I'll give you 2 weeks to do that, and 2 weeks for this car details one as well. Right, so with this one I kind of conclude the Python intermediate part for data wrangling. There will be other complex data wrangling operations like merging on index or concatenating index values, but those will be somewhat extra burden. But I will do an advanced Python wrangling process at the end of the lecture series. But for the coming lectures, I am thinking of doing some text analytics and some sort of hands-on exercises. So it will be really beneficial for you when you are working in the industry, as well as doing any research activities in the future. So by the subject content, we have covered 80% to 85% of the subject content in terms of data wrangling. Now with this one, you can actually go ahead and do a lot of complex work as well. There will be some advanced handling, so we'll learn about them as the due time comes. So that's about it. Please complete whatever missing submissions there are, and also the relevant submissions that I have mentioned right now. If you don't have any question, you can leave the session. So we'll meet next time.